shape. Okay, this is specialized for more than 2 atom. Okay, example methane. Tadi ada F kan? This one is methane. Okay. Okay, symmetrical. Saya bawa ke kanan sikit. Yeah. Saya tak boleh ni. Okay. First, all terminal atom same. Same example methane. Ada lagi tak yang lain? Methane lah contoh yang mudah. Okay, second, no lone pair. Okay, no lone pair. Example carbon dioxide tadi. Okay, no lone pair at central atom. No lone pair. Okay, example NH ammonia. Ammonia have lone pair, so this is polar. But carbon dioxide is non-polar. Okay, carbon dioxide have polar bond, but because of it have no lone pair and have symmetrical shape, so this is non-polar molecule. Okay, so itu dua lah properties for non-polar molecule. First, have no polar bond. Second, symmetrical shape. Tambah sikit. Symmetrical shape but have polar bond. Okay. Symmetrical shape and have polar bond. So, they have polar bond. But because all the terminal atom is equal, so there is no polar bond anymore. Kenapa? Apa reason nak bagi? Partial positif, partial negatif. Okay, macam ni lah. Okay, they have polar bond. Okay, but non-polar molecule because if they have symmetrical shape, if the molecule have symmetrical shape, if have symmetrical shape, okay, it will cancel out. Net dipole moment. Net dipole moment yang arrow tadi. Okay. All the force is equal from all direction. Sama je force dia. So we assume there is no dipole moment anymore. So that's why it exists as polar and non-polar molecule. Okay, same concept to the carbon dioxide. Carbon dioxide have polar bond. Okay, have polar bond, but because of the it has symmetrical shape. Okay, so the net dipole moment can be cancel out. Itu dia term dia lah. Cancel out Okay, kelas boleh faham ke? Respon sikit. Boleh
Boleh saya.
Kalau tak boleh, okay, kamu kena refer balik lah saya punya nota. Okay, so that's all for the polar bond polarity of molecule. Kita akan tengoklah beberapa contoh. Kat mana saya nak tengok contoh Tadi saya ada bagi link website tau. Website ni bagus. Ni. Esmere College ni kan. Okay. Ni ada gambar-gambar lagi. Okay. Baguslah benda website ni. Maklumat tambahan untuk kamu lah Sambil-sambil tu saya share lah apa website yang saya refer kan. Saya nak tengok latihan dia, dia bagi latihan. Mana? Covalent structure, ada tak pasal bond? Polarity. Okay, molecule polarity Okay, kelas. Cuba kita tengok yang ni. Okay. Mana ni? Okay. BF3 lah, BF3. Cuba tengok question number 2. BF3 BF3 and silicon chloride. Okay, cuba kita tengok. Example. Okay. First, BF3. Second, silicon chloride. Apa dia punya formula tadi? Cl4. Cl4 BF3. Okay, first, how to identify the polarity? You have to draw the Lewis structure. Okay, Lewis structure is very important. If you cannot draw Lewis structure, you cannot determine the shape of the molecule. So B, boron is group 3, 3 valence electron, 3, 7. So 24 semua. Or have 12 pair. So B. Okay, F. Jangan tak mau. Tak marah. Okay, so complete the lone pair. Cukup tak 12? 3, 9, 12. Okay, this is boron fluoride. So boron fluoride has 3 terminal atom. Based on Vespo theory, this is apa ni? This is trigonal planar. Dia macam ni lah, trigonal planar. Okay. So this is geometry shape. Okay, which is has 120 degree angle. Okay. So this is polar bond. It has polar bond. Okay, polar bond. If you calculate the electronegativity, it has polar bond. This is polar bond. Okay, and it has net dipole moment, of course, because it has polar bond. Okay, and there is lone pair. Ada lone pair tak? No lone pair. And the terminal atom is same. So this is okay. Polar or non-polar molecule. Kamu kuat ni dia. Masih apa molekul jawab? Polar molecule or non-polar molecule? Hello, testing.
No, non-polar molecule.
Yes, good.
Non-polar.
Non-polar molecule. So this is non-polar molecule. Non-polar molecule. But it has polar bond. Ingat tu. Okay, non-polar molecule can have polar bond and can have no polar bond. Okay. Second, silicon chloride. Silicon group apa? Silicon, ingat tak?
Saya rasa 14 sir.
14 bawah carbon. Okay, kalau
Group 14.
14 so 4. Alamak. Kira dia punya valence electron. Okay, 7, 4. Okay. 32 32 or 16. Right. 16. Okay. Okay, so 16 pair silicon. 1, 2, 3, 4. Okay. This is tetrahedral. Tetrahedral. Okay. 3, 6, 9, 12. Okay. 16. Cukup? 3, 6, 9, 12, 12, 13, 14, 15. Okay, cukup 16. Okay. So no lone pair, right? No lone pair at the central atom, central atom, no lone pair, and all the terminal atom is equal. So this is also non-polar molecule. Non-polar molecule. Okay. Okay, kelas. Under Lewis structure ada sikit lagi saya nak masuk Lewis structure. How to identify polar. Okay, ni selesai tajuk ni. Polar molecule and non-polar molecule. Okay, Lewis structure. There are a few things that you have to know under Lewis structure. First, what is called resonance? Resonance Pernah dengar tak resonance?
Dia ada different placement
Dalam fizik.
bond dia.
Resonance meaning that double bond have more than one location. Okay. More than one location. Example O3. Okay, O3 cuba draw O3, Lewis structure for O3. Kamu akan dapat macam ni lah. 3 6 18 or 9 pair O. Okay. Okay, make sure terminal atom become octet. 2, 3, 4, 5, 6, 7, 8, 9. Okay. Okay, so this is Lewis structure for ozone or O3. Okay, but the actual formula macam ni okay. O double bond O. Okay, kenapa tahu tak? Kenapa tiba-tiba saya buat structure dia macam ni?
Sebab dia nak dia nak octetkan yang central.
Yes.
Yes, we have to make sure that central atom also become octet, right? So form another double bond from the terminal atom lah. Because of the terminal atom is equal, same atom, so either one. Kamu nak buat double bond at left hand side or right hand side. Okay, mana-mana pun boleh. Okay, but boleh tak kalau saya kata begini pun boleh? Kan? It have two probability. Oxygen, double bond. Boleh tak macam tu? Boleh kan?
Boleh.
Ni oxygen. Ingat this is not rotation This is not rotation. But double bond change the position. This is oxygen 2, oxygen 3. Oxygen 1, 2, oxygen 3. Okay. From the structure 1, okay, double bond located in between oxygen 1 and oxygen 2. But structure 2, double bond located at in between oxygen 2 and oxygen 3. Okay, either one. Okay, this is called as resonance. Resonance because double bond have two or more position in the molecule. Okay, apa lagi contoh lain saya nak bagi apa lagi selain pada ozon? Ada lagi lah banyak contoh yang lain.
Sulfur dioxide.
Sulfur dioxide, good. Sulfur dioxide. Example yang lain Example yang lain, sulfur dioxide. Okay, sulfur. Tak nak lah sulfur dioxide. Okay, cukuplah saya bagi tahu yang tu lah dulu. Okay, next. After resonance, okay, tolong take note ni. Tolong fokus betul-betul. Okay, actually sebenarnya ini adalah HL punya topik tapi saya tak tahu kenapa masuk test. Okay, masuk test. Sebab tu saya ajar. You have to know how to calculate formal charge. Formal charge. Okay, formal charge is used to identify more preferable structure. Okay, formal charge is used if the molecule have more than one structure. More than one structure. Example, apa saya nak bagi Lewis structure sekejap. Okay, ada tak ada nota saya? Resonance. Okay, formal charge. Okay, example saya bagi. Okay, example 1 is sulfate ion sulfate ion. Okay, example sulfate ion. Okay, draw the Lewis structure for sulfate ion. Kamu akan dapat apa? 6 plus 4 6 minus plus 2 plus 2 because 2 negative. Okay, 24 6 30 32. Okay, 32 electron or in have 16 pairs. Okay, 16 pairs. Okay, so draw your Lewis structure. Buat sama kamu kena draw juga. So sulfur, oksigen, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, and then do a bracket. So this is your Lewis structure for sulfate ion. And actually each atom in molecule have their own charge, which is called formal charge. So how to calculate formal charge? Okay. Kalisha tak mau kacau abang. Kalisha tak mau kacau abang. Okay, how to calculate formal charge? Formal charge equal to number of valence electron minus bracket number of lone pair plus number of bonding pair number of bonding pair divide 2. Bak sini. Bak ready. Okay. Boleh dapat formula ni? Okay. Sekejap. Hello semua, ada lagi?
Hello sir.
Okay, so you have to calculate the every atom formal charge. By using this formula. Saya tunjuk satu contoh. Okay, oxygen 1 ni oxygen 1, oxygen 2, 3, 4 and sulfur 1 lah. Okay, calculate the formal charge for oxygen 1. Okay, ni formula kalau kamu tengok dalam reference book ataupun ni nampak panjang tapi sebenarnya simple je. Saya ajar cara dia mudah Okay, what's the valence electron for oxygen? 6. Right. Oxygen 6. Okay, minus, right? Minus. Okay, first how to calculate the minus. Okay, this is 2 1, 2, 3, 4, 5, 6, 7. Minus 7 dapat berapa? Itu cara dia. Negative 1. So, this is negative 1. Okay. Alright. So, what is the formal charge for oxygen 2? Tengok cara saya kira. Okay. Valence electron 6. Okay, tengok pair ni ada 2 elektron kan? 1, 2, 3, 4, 5, 6.
Boleh repeat tak? Saya tak faham.
Okay. Ni saya repeat ni. Tengok saya repeat semula. Tengok cara dia macam mana First, your valence electron berapa? Valence electron 6, right? 6. And then nak minus berapa ni? Kalau tengok formula tu pening. From Lewis structure kita boleh tahu dah. Tengok Yang ni 2 elektron kan? 1, 2, atas 4, 6. 6 tambah dengan dekat bonding pair ni ada 1 elektron oksigen tu. Ambil oksigen punya je. Lagi sekali saya ulang. 1, 2, 3, 4, 5, 6, 7. Okay. So minus 7 akan dapat negative 1. So the charge here is negative 1. Okay.
Cikgu. Tapi macam mana dengan number of bonding pair divided by 2 tu?
Okay, divide by 2 tu ada number ni lah. Bonding pair yang ni. Bonding pair ni ada 2 kan ni. This is have 2 electron, right?
Ya.
Kalau divide by 2 dapat berapa?
Divided by 2, 1.
1 elektron kan?
Ya.
1 elektron tu yang ini. This one. Ni yang kat atas ni. 1 elektron. Itu maksud dia. Okay, number of bonding, number of lone pair. Lone pair yang ini saya buat pakai pen merah 1, 2, 3, betul? Ada 6 elektron kan?
Ya.
6 elektron tambah dengan bonding pair divide by 2. Divide by 2 sebab dekat dalam bonding pair ni have 1 electron from oxygen. Betul tak?
Betul.
Tu je cara dia. So, 2, 4, 6, 7. Minus 7 dapat negative 1. So, lagi sekali saya ulang dekat oxygen 3 Oxygen 3, 6 minus, 6 tu is valence electron. Standard valence electron for oxygen. Minus lone pair. 1, 2, 3, 4, 5, 6. Plus dengan bonding pair divide by 2 kan? 6, 7. Okay. Negative 1. So, discharge also negative 1. So, nombor 4 pun sebenarnya samalah akan dapat negative 1. Okay, cuba kirakan sulfur punya formal charge berapa? What is the formal charge for sulfur? Sulfur has 6 valence electron. Sulfur 6 minus berapa?
2 ego. 6 minus 2.
Okay, minus, ada tak lone pair? No kan? No lone pair. Okay, bonding pair. 1, 2, 3, 4. Okay, divide by 4 akan dapat 2 positive, right? Akan dapat 2 positive charge dia. Okay, so this is called formal charge. Okay, actually in this all atom in molecule
Sir.
formal charge. Okay, apa dia?
Sir, 4 tu bukan kena divide by 2 ke?
Betul. Divide by 2 ego.
Okay, bukan 4 tu divide by 2. Total bonding electron berapa? Total bonding electron ini ni. 2, 4, 6, 8, betul?
Oh.
Total, bukan total bonding tu, total elektron.
Betul nombor.
2, 4, 6, 8 divide by 2, 4 lah kan?
Betul.
Nak dapat positive 2. Okay.
Alright.
What is mean by formal charge? Tengok formal charge 0 shows the more stable structure. Saya ulang semula. If formal charge is 0, meaning that atom is stable. So in this case, the atom is not stable. Oxygen negative, sulfur positive 2. It should be all the atom become negative, become 0. Baru dia akan lagi stable. Okay, so what is mean by negative charge? Negatif tengok betul-betul kelas, dengar betul-betul saya cakap. Negative charge ni negatif This one, negative. Nak pakai pen color apa ni, biru lah. Negative charge Negative meaning that this atom have to share their one lone pair to the central atom. So negative maksudnya oxygen have tendency to donate lah, to share their lone pair to the sulfur. What is mean by positive 2 charge? Positive meaning that sulfur need 2 more lone pair. Saya contoh kat sini senang nampak. Okay, need 2 lone pair. Tengok ayat saya lone pair bukan elektron. Dia perlukan lagi 2 lone pair. Negatif maksudnya donate ataupun share, donate lone pair. So in this case, we have 4 oxygen, right? 4 oxygen must donate their lone pair to the sulfur, but sulfur just need 2 more lone pair. Jadi apa yang berlaku adalah, cuba tengok structure dia macam ni. Saya boleh draw begini Okay, this is second structure lah for sulfur. Okay. Alright. Ni after it donate the lone pair lah. Okay. Tadi oxygen 1 donate lone pair dekat sini. Oxygen 3 pun dah donate. Okay kelas, cuba kira balik formal charge. Tengok formal charge for oxygen 1. Kat sini kalau saya kira akan dapat 24, 5, 6. Akan dapat 0 Yang atas ni kamu akan dapat negative 1, 0. This one is 0. This one is negative 1. Sulfur sulfur 6. 1, 2, 3, 4, 5, 6. Okay, 0. Nampak tak? How many 0 kat dalam tu? 1, 2, 3, 4. Oxygen 1 have formal charge 0. Oxygen 2 have formal charge negative 1. Oxygen 3 formal charge 0. Oxygen 4 negative 1. Sulfur 0. Nampak? Compare before it donates the lone pair. Dia ada apa tu? Oxygen 1 negative 1. Oxygen 2 negative 2. Oxygen 3 negative 1. Oxygen 4 negative 1. Sulfur positive 2. Nampak tak? There is no atom that achieve 0 charge. Semua ada charge So the more the number of atom have 0 charge, the more stable of the Lewis structure. Okay, the more stable the Lewis structure. Okay. So bila nak guna ni? When you have more than 2 possibility Lewis structure katalah kamu draw Lewis structure, ada 2 possibility. Yang mana satu formula yang paling tepat? Yang atas ni ke yang bawah? So calculate the formal charge for every atom. The more the number of atom that have 0, the more the stable the atom. So that is the more preferable Lewis structure. Okay. Tanpa tak nak pening kepala, guna je formula ni. Okay. Biasanya kalau dalam exam soalan akan keluarkan macam ni. Dia buat oxygen 1, oxygen 2, sulfur. Okay, calculate the formal charge. So just use the formula, calculate the formal charge. Itu saja. Boleh faham gunalah formula yang sebagi. Kalau oksigen macam mana? Valence elektron minus number of lone pair 2, 4, 6 plus 1/2 bonding pair 2, 4 kan. Apa jawapan dia? Kira lah macam tu, ikut je formula yang saya bagi. Okay. So tulis shows the calculation and shows the charge. Okay. Kalau satu tulis positive 1, jangan buat 1 je, positive 1 sebab this is charge, right? Ada setengah pelajar kadang kalau jawapan dia 1 kan, dia buat 1. Salah. If your answer is positive, write the answer including the charge. Example positive 1 ni. Okay. So that is for the formal charge. Formal charge. Okay. Okay kelas, okay ke?
Sir, I have question.
Okay, boleh tanya. Silakan.
Sir, kan dia kata formula tu number of lone pair kan?
Okay.
Tapi maksudnya sebenarnya number of electron in lone pair tu kan?
Okay, yang maksudnya sini adalah kalau maksud saya adalah lone pair ni maksudnya dia kena donate, dia kena bagi dua-dua elektron tu sekali lah. Kan contohnya yang dia bersini tadi. Contohnya yang ni kan. Dia sepatutnya macam ni. Oksigen. Sekarang dia donate lone pair dia ni dekat sulfur. Okay. So tak ada lah. Lone pair dia dah tak ada. Maksudnya lone pair ni berapa? 2 electron. So if I said donate 1 lone pair, meaning that it donates 2 electron lah to the central atom. Okay. Cuba tengok sulfur. Sulfur 2 positif. Maksudnya sulfur need 2 more lone pair ataupun elektron. 4 elektron lah. Nampak tak? But in bonding, it cannot donate 1 electron because every bonding are made up from 2 pair of electron. Saya tak boleh cakap macam ni. Okay, oksigen ni donate 1 elektron sahaja. Tak boleh, dia tak ada partner. Bonding tu tak boleh terbentuk. The bonding cannot be formed. Okay, it have to donate the pair of electron at one time. Okay, baru it can form lone pair. Okay, sulfur more than octet. Nampak tak? Yes, sulfur more than octet. Saya dah ajar dalam kelas hari tu because sulfur have exception. Okay, sulfur can achieve 6 covalent bond. Sulfur exception, ingat balik saya ajar tu. Sulfur, phosphorus. Okay, this atom are exception. It can form more than octet. Yang pelik pula, so kenapa sulfur lebih octet ni? Yes, it can form more than octet for sulfur and phosphorus. In our syllabus lah, in our syllabus. Actually, there are a few atom lagi. But in our syllabus, kita fokus sulfur and phosphorus as a extended octet. Okay. Right. Tapi kalau tak okay, saya akan hantar video lah. Saya cubalah. Kekangan saya adalah ada kanak-kanak ni kan. Okay. Ada pula soalan kat sebelah ni. Allahuakbar. Lupa pula. Okay. Okay, kita akan masuk kepada intermolecular force. Intermolecular force. But saya nak share je lah kat sini jawapan dekat dalam nota yang saya bagi ni. Okay, jawapannya ni Okay, sulfur dioxide, sulfur. Kalau kita belajar sulfur dioxide, what is the formula sulfur dioxide? 6 plus 2, 6. 6, 12, tambah 6, 18. Okay, O 9 pair. Sulfur, oksigen. 8, 9. Nampak Okay, this is sulfur dioxide. So how to make sure this formula is accurate? Betul ke this is Lewis structure for sulfur dioxide? we have a few possibility cuba tengok sini. We have a few possibility. Oxygen. Okay, oxygen have high tendency to form double bond because oxygen need 2 more electron. Okay, sebab tu dia ada possibility. Okay, cuba tengok dekat sini. Oxygen. Okay. Satu lagi structure saya nak tunjuk. Oxygen. Okay, before we proceed. Okay, kelas, cuba kira formal charge and which one is the more preferable structure. Ada 3 kemungkinan ni. Sebab sulfur can form more than octet and oxygen have tendency to form double bond. Okay, cuba kira-kira kat sini. This one is -1. Kan ikut formula lah. Kalau kamu mahir nanti kamu boleh congak je. 6, 1, 2, 3, 4. So, positive 2. 1, 2, 3, 4, 5, 6, 7. -1. Okay. Okay, yang tengah ni pula. Okay, this is 0. Kita boleh agak dah. -1. Okay. 1, 2, 3, 4, 5. Positive 1. Okay. This one is 0. This one is 0. 0. Okay. Cuba tengok kat sini. Which molecule have more atom have 0 charge? Yang mana satu?
Yang last tu cikgu.
Belah kanan sekali kan? Okay, belah kanan. Maksudnya yang ini adalah the more preferable Lewis structure. Okay. Not the ni bukan. Middle ni pun bukan. Okay. So this is Lewis structure for sulfur. What is the geometry? Apa geometri dia ni? Geometri sulfur one. Macam ni lah sebenarnya. Okay, so this is band band or V shape. Okay, it have one lone pair. Okay, so if it have one lone pair, so this is asymmetry. Asymmetry. So it exists as non-polar. It exists as polar molecule. Polar molecule. Okay, sulfur dioxide is polar molecule. So you have to make sure you can identify which one is polar molecule and non-polar molecule. But first, make sure draw the Lewis structure and then follow the rule. So identify the polar molecule and non-polar molecule. Okay. Okay. So relax dulu. Okay, kita nak tengok pada bonding pula
So nak tanya,
Okay, silakan.
yang kalau kita dah lukis banyak-banyak tu,
Okay.
kalau nak pilih more preferable, kita pilih yang banyak kosong
Yes, the more the number atom have 0 ni maksudnya dia charge the 0 ni stable kan? So the more 0 meaning that more atom is stable. So that one is the best option as a Lewis structure. Boleh faham Kalau banyak charge maksudnya atom kat dalam tu tak stable. So itu adalah bukan structure dia yang sebenar. Okay.
Okay, sir.
Okay. So ni sikit lagi. Intermolecular force. Okay. Intermolecular force. Boleh kita teruskan lagi Intermolecular force. Or in simple words, we call it as kita panggil dia sebagai IMF lah. Kalau saya kata IMF tu intermolecular force. Okay, apa yang kamu nak belajar Intermolecular force. intermolecular force. Okay, intermolecular force apa dia? First, make sure you know the meaning of intermolecular force is electrostatic attraction between electrostatic attraction between
gaseous molecules.
between two atoms lah. Electrostatic attraction. Satu lagi. Between two sharing electron kan? Pair of atom. Ataupun bahasa mudahnya, this is for covalent bond lah. Intermolecular force is specialized for covalent bond. So intermolecular force are divided into three. First we call it as London force or dispersion force. London force or dispersion force. What is the London force or dispersion force? Ada tiga saya bagi tahu dulu lah. London force or dispersion force. Second, dipole force. Third, hydrogen bond. Hydrogen bond. So we go to the first force, which is London force. So what is London or dispersion force? This is usually in non-polar diatomic molecule. Biasanya, usually in non-polar diatomic molecule, but also have in polar molecule. Dalam polar molekul pun ada, tapi biasanya contoh kita gunakan non-polar. Cuba tengok sini. Non-polar ni ada banyak lah. Cl2, O2, N2, Br2 and so on. So I just use Cl2 example. 1 Cl2. So structure dia Cl, Cn. Ini adalah elektron. Dari structure untuk klorin saya padam balik lah. Cn, elektron. Boleh bayang macam ni. This is molecule for chlorine. And we know that chlorine is non-polar because electronegativity is 0. This is non-polar bond. Tengok sini. The process. Saya tunjuk process 1. We know that the electron are move freely. Electron always move freely in the atom. It always moving surrounding the nucleus. At the one time, all chlorine and all electron can accumulated at one area. They can accumulated at one area. Macam ni. Tiba-tiba elektron ni semua berkumpul dekat tengah. So what happen when all of the electron in we assume this is chlorine 1 This is chlorine 1, this is chlorine 2 lah. Okay, what happen if all the electron in chlorine 1 accumulated at the double bond, accumulated at the covalent bond. Okay, kat sini dia akan jadi partial positive because any region that have poor electron will become partial positive and region that have rich electron become partial negative. Okay, cuba tengok sini. Electron is negative charge. Electron negative. So this negative dia akan repel with the same electron Okay, so last kali dia akan jadi macam ni. Electron. Okay. Okay. First, electron are moved randomly in the atom, and at certain time, not all time, at a certain time, electron can be accumulated at the covalent bond, and when it accumulated at the covalent bond, this electron will repel the neighbor atom electron. So this neighbor atom electron also dia akan berkumpul di sebelah kanan juga. Dia akan jadi macam ni lah. Okay, dia akan berkumpul di sebelah kanan. Okay, so the region that have rich electron will become partial negative. Region that have less electron become partial positive. Okay, so this is called polarized. Boleh faham Okay, this situation is called polarized. So chlorine molecule is polarized. Polarized ni maksud dia akan jadi polar bond lah. Okay, but just temporary. Not permanent. Temporary. Not permanent because after a few seconds it will become non-polar bond again. Okay, temporary. Itu maksud temporary. Sementara je because electron always moving. So after a few seconds, okay, this polarization is gone. Dia akan hilang. Dia akan jadi neutral balik. Okay. So this is the situation under London dispersion force. Okay. So the atom that starting the polarization, chlorine 1 ni kan, chlorine 1 that start the polarization is called instantaneous dipole. Okay. The neighbors atom that polarized from the chlorine 1 is called induced dipole. So in London dispersion force, it involves two roles of atom. First atom trigger the polarization, which is chlorine 1. Second atom induce the dipole. Induce ni maksudnya dia affected by the chlorine 1 tadi ni. Dia yang terpengaruh dengan chlorine yang satu lagi. We call it an induced dipole. So what happen is now the non-polar bond have polarized, which is it have a partial positive and it have partial negative, but this is just temporary, not permanent. Okay, after a few seconds, the electron will move to the other area and the polarization is gone. Okay. Okay. Boleh faham sampai situ proses ni? Okay. So next, when the chlorine atom become polarized, kita tengok chlorine atom dah polarized dia ni. Okay. Partial positive, partial negative. What happen is it will attracted to the another chlorine atom. Okay. It will attracted to the another chlorine atom that have opposite charge. Okay. Macam ni. So this chlorine atom also attracted to the another chlorine atom. Okay, partial positive, partial negative.
Saya nak tanya. Yang garis biru-biru tu apa?
Okay, yang biru-biru. Okay, good. Yang biru-biru, this is called dipole pula. London force. London force. Okay, ingat intermolecular force is attraction between molecule and molecule. Saya ulang semula. Kan pelajar salah, intermolecular force attraction between molecule and molecule, not atom inside molecule. So where is London force? London force actually is the force between molecule and molecule. But how this force is formed? Okay, when the molecule polarized for a temporary. Ni atas ni, daripada atas ni case dia. Okay. Tapi don't worry lah, in exam you don't have to explain the step by step. Just theory saja, kamu kena tahu which one is London force. You faham
Sir,
dalam exam tak ada. Okay.
Sir cakap tadi polarized tu maksudnya apa?
Polarized ni maksudnya from non-polar become polar bond. Boleh faham tak?
Oh,
Dia kan non-polar kan? Non-polar and then it become polar bond tapi not temporary, just not permanent, just temporary, a few second only. Okay, it just a few second. Maksudnya London force ni dia kejap ada, kejap tak ada. Dia ada hilang macam tu. Faham tak? London force ni. That is why London force is the weakest intermolecular force. Okay. London force weakest paling lemah. Weakest intermolecular force. Sebab dia temporary. Temporary maksudnya just a few second. After a few second dia ada balik. Boleh faham tak? Dia macam kejap ada, kejap tak ada. Tu London force. Okay? boleh faham ke? So in your IB exam, you don't have to explain the process one by one. This is just concept. Okay? But in your exam, you have to identify which molecule is undergoes London force. Senang je. Okay, atom that have same type of molecule that have same type of atom adalah London force. Itu je. Okay, Cl2, O2, N2, apa lagi? Okay, all molecule that are made up from same type of atom, all of them undergoes London force. Okay. Okay, but it's just the process. I just want to explain the process how London force is formed. Okay. Don't forget there are two rules here. First is called instantaneous dipole, and second induced dipole. Okay. So this is London dispersion force. Okay, next. London force. Second is dipole force. Okay.
Saya nak take 5 sekejap. Meeting yang ni.
Okay. Apa? Meeting?
Nak bincang sikit dengan Nick. Nak take 5 sekejap.
Okay. Silakan. Yang lain okay?
Okay, cikgu.
Yang lain ada apa-apa nak tanya ke?
Saya nak tanya,
Okay.
kalau kan sebenarnya kan kalau dia ada juga kan polymolekul kan. Jadi dia punya like, prosesnya kan sama je lah.
Proses dia sama je, tapi dia ada dalam polar molekul, tapi tak perlu fokus into biasanya London force ni dia more to non-polar. Polar molekul ni dia ada dua, dia ada London force, dia ada dipole force. So biasanya kalau dalam test kamu nampak polar bond je, dia adalah dipole force. Kalau non polar bond, dia adalah London force. Okay. Just kamu kena tahu je dekat dalam polar molekul pun ada juga London force, tapi dia tak banyak lah. Okay. Okay. Okay, apa yang saya buat ni semua ada dalam nota yang saya screenshot tu, yang saya bagi kat dalam WhatsApp. Kamu boleh buka balik nota saya tu. Lebih kurang samalah lukisan dia semua. Okay. Boleh ke kita proceed Dipole boleh? Okay. Dipole force. Okay, usually in non polar bond ataupun non polar molekul lah. If the molecule have non-polar bond, okay, it has dipole force. This is in between molecule. Okay, saya padam ni ya. Okay. Which atom, which molecule undergoes dipole force? Usually if the molecule have non-polar. Macam salah je ayat saya ni. If the molecule have polar bond. Okay, maaf, sorry. If the molecule have polar bond. Okay. If in the molecule have polar bond, it have the dipole force in between molecule. Okay. Okay. Mana saya ni tadi? Okay. So example lah. Which molecule is polar bond? Saya bagi satu contoh. Yeah. Okay, siapa ni example saya pilih saya pilih HBr example. Nah. Okay, example. I choose HBr. Example HBr. So HBr is polar bond. Polar bond, it has electronegativity more than 0.4. Okay, hello. Okay. Kasha tengok video kat bawah. Okay, this is polar bond. Okay, why polar bond? Because it has partial positive and partial negative. This polar bond is permanent. Not same as apa tadi? London force. London force, it from the non-polar molecule, non-polar bond. It from the non-polar bond. From the non-polar bond, it can form polar bond for a temporary. Okay, that's why it form dipole London force. But for the dipole force, okay, usually is polar molecule that have polar bond. Example HBr. Okay, HBr. So what happen is, okay, HBr. Okay, when it come closer to the another HBr, it will have attraction. Okay, attraction. HBr. Okay, attraction. Okay, from partial positive and from partial negative. Hydrogen partial positive, Al partial negative. Okay. So daripada force is attraction. Attraction between berapa kali between ni? Attraction between partial positive, okay, attraction between partial positive to partial negative of other molecule. Okay. Ni the attraction partial positive to the partial negative of other molecule. Nampak ni molekul A, molekul B, molekul C. In molecule A, okay, partial negative attracted to the partial positive from molecule B. Nampak? And in molecule B, the partial negative are attracted to the partial positive from molecule C. And this process is continuously lah. Continuously. So which one is more stronger? Therefore the full force is more stronger than London force because this is permanent. Permanent, kekal, dia takkan hilang. Okay, so this is dipole force. It is permanent. It's permanent. Okay, permanent. So dipole force is more stronger than London. Okay. So that's all for the London force. Simple je, London force simple. Okay, ingat je, dia adalah polar bond, and then polar bond have partial positive, partial negative, and partial positive or partial negative of from the atom attracted to the opposite charge from another molecule. Okay, this example lah. Okay, so number 3. Okay, number 3 is hydrogen bond. Hydrogen bonding. Okay, hydrogen bonding. What is hydrogen bonding? Hydrogen bonding is attraction between hydrogen atom to nitrogen. Ingat phone ingat dia katakan phone. To fluorine, oxygen and nitrogen from other molecule. Okay, attraction between hydrogen atom to fluorine, oxygen or nitrogen from other molecule. Okay, example water. Water H2O. H2O. So oxygen hydrogen. Okay, example Buat ini. Okay. Okay. So example water water hydrogen will attract hydrogen is partial positive, oxygen partial negative, partial positive, partial negative. Okay. So hydrogen attracted to the lone pair, attracted to the lone pair of oxygen from another molecule. Okay. So mana lagi ni? Macam ni lah. So this hydrogen attracted to the oxygen from another molecule. Okay, so this is hydrogen bond. Tengoklah pula. Another example, ammonia. Ammonia. Okay, ammonia NH3. Example lah, another example NH3. Okay, NH H okay. So the nitrogen from another molecule. Okay. So this hydrogen, okay, attracted to the nitrogen from another molecule also. Okay. Macam ni lah contoh. Okay. So continuously lah. Okay. So make sure the bonding are between hydrogen to nitrogen, oxygen or fluorine. Okay. So this is hydrogen bond. And this is not hydrogen bond. Contoh hydrogen bond. Saya bagi satu contoh. Apa hydrogen bond. Okey, contoh CH3 Okey. Okay, this is not hydrogen bond. This is not hydrogen bond. Okay, why not hydrogen bond? Okay, in hydrogen bond, make sure intermolecular force, intramolecular, and intermolecular. Okay, it's between oxygen, nitrogen, fluorine, and hydrogen. Okay, so in this case, okay, yes, intermolecular, inter ni in between molecule, in between molecule. Intra ni inside atom, inside molecule. Okay, for hydrogen bond, make sure intramolecular also in between hydrogen, in between empat-empat ni lah. Okay. So in this situation, oxygen are not bonding to the carbon. Okay, bonding to the carbon. Okay, oxygen bonding to carbon. Dapat carbon. So this is not hydrogen bond. Okay, compare to yang contoh atas saya bagi ni. Okay, oxygen, hydrogen. Okay, this is intramolecular, and intermolecular also hydrogen, oxygen. Nampak this is hydrogen bond. Yang bawah ni bukan, sebab apa? Yes, intermolecular O dengan H, but intramolecular ataupun inside molecule, oxygen are combined to to atom other than O and F and H. Okay. Example ammonia. Yes, in ammonia intermolecular NH, right? And intermolecular also NH. The in between O and F and H. Okay, if the intermolecular and intramolecular is in between O and FH, this is hydrogen bond. If not, it's not assumed as hydrogen bond. Okay, so this structure is not hydrogen bond. Okay, not hydrogen bond. Kena make sure tu, kena beza kan. Kalau dalam test dia bagi contoh, you have to draw first the structure and then cuba tengok intramolecular and intermolecular dia. Adakah O and FH? Okay. Okay. So that's all for the hydrogen bond. Okay. Boleh kelas? Ada lagi ke ni?
Cikgu. Jadi kalau hydrogen bond tu, kalau dia nak meet the requirement, kena ada both intra dengan intermolecular.
Yes. Yang O and FH tu kena ada in between, intramolecular and intermolecular, dua-dua kena ada.
Okay.
Kalau contoh yang saya bagi ni tak ada kan, dia tak dikira sebagai hydrogen bond. Okay, biasanya pelajar ada tengok yang intermolecular je, OH, hydrogen bond. Tak boleh, kena tengok juga intramolecular dalam bonding tu. Okay. Contoh kes yang ni pula kan, yang ni hydrogen dia combine with carbon tak ada dalam list ni pun tak boleh jugalah, nampak so this is not hydrogen bond. Okay, tolong take note yang tu. So this is hydrogen bond. So kita buat list hydrogen bond is more stronger than dipole. Dipole force, and dipole force is more stronger than London force. London force. Okay, certain dalam IB juga kita assume London force is a van der Waals force. Van der Waals force. So kalau kamu jumpa soalan dia kata van der Waals tu, maksudnya dia refer kepada London force. Okay, this is in term of strength. Okay, bila strength maksudnya apa? Melting point for hydrogen bond tinggi, and then melting point for London force is low. Faham Okay, boiling point at hydrogen bond high, dipole force middle, and London force boiling point is low. Ingat tu. Okay, apa lagi kita boleh relate? Strength. Okay, what strength ni rendah. Okay. Okay, this is summarization lah. Kita habis pukul 10 ni. Okay tak semua? Saya nak masuk sikit je lagi.
Okay, sir.
Sikit lagi. Satu lagi kita panggil sebagai metallic bond. Last sekali. Metallic bond is not intermolecular force. Don't get confused. Metallic bond is another force of attraction. Okay, the next is metallic bond. Metallic bond. Okay, metallic bond actually in metal lah. Bonding in metal. Okay, so this is metal. Okay, apa metal kita nak guna kelas? Example saya guna magnesium. Magnesium metal. Okay, metal is solid. Solid, we know that metal is solid. So what is the structure of solid? Solid macam ni, right? Solid is the structure of solid. Okay, solid. Okay, this is magnesium metal. Okay, but how it can bond to each other and why the bonding is more stronger compared to others bonding? Okay, actually okay, in magnesium, okay, kita zoom lah zoom, saya besarkan dia. Actually magnesium, okay, this is magnesium. Okay, shell. Okay, this is shell magnesium. Have 2 electron. Group 2, right? Group 2. Okay. 2 electron. Okay. Okay, another magnesium. Nucleus. Shell. Okay, another magnesium. Okay, abaikan number of shell tu number of shell tak cukup pun tak apa, saya nak bagi contoh je. Okay, example lah ini. Okay, ni kat saya close up lah when we close up. Okay, class tu magnesium have 2 valence electron. What is the properties of metal? Metal, they have tendency to lose electron. Betul tak? Metal have tendency to lose electron. Okay, so tengok okay, this valence electron, we just focus on valence electron. This valence electron are attracted to the nucleus because nucleus have positive charge. Betul? Okay. And this electron, valence electron, also attracted to the nucleus. Okay, attracted. Okay. And this valence electron are attracted to the another magnesium nucleus. So what happen is when it donate valence electron, it will become ion. Dia akan jadi ion So magnesium sekarang akan jadi ion. Okay. Mg2 plus magnesium. Okay. Saya buat berapa contoh lah. Okay. Mg. Tajuk ni banyak kena lukis. Okay, tu positif. Okay. Where is the electron? Electron now moving. Okay. Dia moving. Alamak, penyerah. Okay, moving. Okay, elektron dah moving Ni elektron. Okay. Yang ni pula dia akan moving lah dekat atom yang lain. Okay, boleh nampak tak Okay. So it start from the atom, but metal atom has tendency to donate valence electron to the another neighbors magnesium atom. Okay, why? Because valence electron are attracted to the nucleus atom Okay, nampak tak? So electron ni dia akan moving around and it always moving. Okay, it always moving. Okay, benda ni continuously. Ni nombor 1, 2, 3. Imagine valence electron from magnesium 1. Okay, go to the magnesium 2 and then from the magnesium 2 it jump to the magnesium 3. Dan it always moving. Benda ni berterusan. It not fixed at the position. Okay, so this is called delocalized electron. Yang electron ni we call it as delocalized electron. What is delocalized electron? Free moving electron. Free moving electron. Yes, mata kasar kita tak nampak lah dalam metal tu kan ada elektron ke. Yes, actually in metal all metal have free moving electron that called delocalized electron. it always jump from one atom to another atom. Okay, because the localized electron, the localized electron ni come from the valence electron lah. Okay, so yang satu lagi ni metallic ion. Metallic ion. So what is metallic bond? Metallic bond, okay, ni definition So what is metallic bond? Metallic bond is electrostatic attraction. Electrostatic. Yeah. Electrostatic attraction between metallic ion to delocalized electron. Delocalized electron. You faham To delocalized electron. Okay, so this is metallic bond. Please remember the definition. Okay, that is why actually structure for the metallic bond begini sebenarnya. Structure dia sebenarnya macam ni. Positive, 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 and in between have the localized electron. Okay, so this is the structure for metallic bond actually, and we call it as lattice structure. Lattice structure. Dekat mana kita belajar hari tu lattice structure? Bond also is called lattice structure. Okay, it's called lattice structure because it have positive and negative particle. Okay. So kalau kamu draw the structure for metallic bond, it have metallic ion and it have delocalized electron. Okay, and it have delocalized electron. Okay, so this attraction is very strong. Very strong. This attraction are very strong. Okay, more stronger than hydrogen bond, London force, or dipole force. Very strong because this is metal. Okay, definition dia tambah sikit lagi. Between metallic ion in lattice structure. In lattice structure. Okay. Okay, sikit lagi kita nak habiskan. What is the properties of metallic bond? Properties. Dah hilang mana? Bawah balik. Okay, metallic bond properties. Okay, what is the properties of metallic bond? Properties. First, apa yang kamu tengok kalau tengok pada metal? It have shiny surface.
Conduct electricity.
Kejap it have shiny surface. Okay, why it have shiny surface? Because okay. Okay, shiny surface. Macam mana saya cakap alamak, lupa ayat dia. Shiny surface apa dah kamu punya handbook? Okay, actually shiny surface come from the free moving of the localized electron. Come from the delocalized electron. Delocalized electron ni dia pantulkan balik cahaya. Okay, saya lupa apa ayat dia. Macam mana cakap?
Reflect light.
Yes, it reflect the light. Yes. Okay, shiny surface. Why metal properties have shiny surface? Because the localized electron. Terima kasih. Okay. Tak ada fikir pula ayat tadi. The localized electron reflect. Ni yang saya cakap tadi, reflect the light. the light. Sebab tu kamu tengok mana-mana metal, dia kilat dia lain sikit. Dia macam metallic kan. Because the valence electron reflect the light. Okay. Next, it have properties apa? Malleability kan. Metallic bond. Apa properties? Malleability. Malleability. What is malleability? Malleability, ability to reform. Ability to deform. Okay, kalau bahasa Melayunya mudah ditempa lah, malleability. Okay, malleability. Why it have malleability? First malleability, second kita call dia and that time. That time ability to stretch into a wire. Banyak wire made up from metal, betul? Wire, kalau wire kat rumah tu kamu kerat dia, dalam tu adalah metal. Okay, so it has malleability at that time. Why? Okay, because metallic ion can rearrange the position and form new lattice structure. Okay, and form new lattice structure when exposed to the force. Okay, example. Okay, ini metal ion. Okay, metal ion Okay. Ada saya punya okay. Okay, when it exposed to the force, the force apa yang form new lattice structure. Okay, dia akan jadi macam ni. Dia faham tak? When it exposed to the force, okay, dia akan berubah bentuk because okay, metallic ion can rearrange the position and form new lattice structure when exposed to the force. Okay, tu je kalau kamu diminta untuk explain lah. Okay, next malleability.
Sir, kalau force tu macam apa? External force ke apa?
External force lah, maksudnya kamu ambil hammer ke, ketuk, dah lekuk kan. Okay, external force. Okay. Okay, next can carry electricity, kan? It can carry electricity. Okay, how it can carry electricity? Okay, simple je nak explain. The localized electron has ability to carry energy. Okay, it can carry energy. To ability of the localized electron. Okay, same concept can conduct heat. Kan, metal can conduct heat. Macam ni kan. Okay, the localized electron okay, gain heat energy, gain heat energy, and increase kinetic energy. Okay, increase kinetic energy. So this delocalized electron akan collide to another electron to distribute the energy. So this is how metal conduct electricity. So kalau yang tak nampak macam ni lah contoh. Dia ni adalah metal. Metal. Imagine this metal. Okay, ni heat. Heat. Okay, ni elektron. This is electron. Okay, heat, and then this electron akan gain kinetic energy and it will move to the cooler area. Okay, it will move to the cooler area, so it will collide to the another electron. It will collide to the another electron. When it collide to another electron, it will transfer the energy. Kenapa? This is high kinetic energy. Okay, it will move to the cooler area. Ni hot area, cool area. And during the movement, it will collide to the another electron. So at the same time, it will distribute the energy. So that is why heat moving from hot area to the cool area. Itu je. So this is the macam mana? Okay.
Dia kelas elektron ni kan. Dia elektron yang being shared between metallic ion
Yes, yang valence electron tadi kan, yang kita nampak ada jump from one atom to another atom tu kan. That one is the localized electron.
Okay.
The localized electron ni maksudnya it not fixed in the valence electron. Dia tak fix dalam valence electron. It always jump from one atom to another atom. Dia faham dia ibarat atom ni dia tengah main pingpong. Kamu bayangkan elektron tu move macam pingpong lah. Dia terpantul-pantul from one atom to the another atom. It always moving. So this movement of electron carry electricity and can conduct heat. Okay. So I think that's all for today lah. Kita dah belajar intermolecular force. Kita dah belajar metallic bond. Okay, cuma saya minta kamu baca sikit lagi lah pasal alloy. Alloy tu tak banyak, sikit je lagi. Okay, and then how to identify polarity molecule kan? Which one polar molecule and which one is non-polar molecule. Okay. Masa yang ada ni, hari ni esok buatlah latihan dalam handbook. Nanti saya akan sharekan jawapan. Okay, boleh ke? Saya dah cukup kan? Aku 10 dah.
Boleh sir. Okay.
Boleh sir.
Okay. So,
Thank you sir.
itulah yang saya boleh bantu. Minta maaf lah sebab kita banyak lost kelas kan. Ada masa saya MC, ada masa jatuh hari cuti. Jadi kita kena buat kelas extra sikit lah. Ya. Bagi tahu parent kamu lah yang kat rumah tu kan dia bising pula kan. Cakap lah ni kelas banyak cancel, banyak kena hari cuti. Okay. Okay, right. So yang lain tu saya akan share video ni saya record ni, saya akan share nanti.
Okay.
Okay. Thank you sir.
Okay.
Sir, test minggu depan. Hari apa?
Minggu depan, hari Senin.
Oh, okay.
Okay, buatlah. Buat latihan dalam handbook tu je saya punya clue. Handbook yang page yang relate dengan bond ni, buat je